Konnichiwa, minasan. Welcome to Shinrai's episode 2 of Math. At any point in time, if you want to pause the video and take a screenshot of the lessons written on the board, please feel free to do so. And at any point in time, if you have any questions, either leave them in the comment section below the video, tag them at Shinrai Sensei 15 on Twitter, or feel free to ask them on my live stream when I have that set up on Patreon. Now, today we're going to be dealing with fractions, and we're going to deal with a couple concepts that will help us do math dealing with fractions. So first, we're going to introduce you to the concepts that will help you with dealing with fractions in mathematics. Instead of getting into the definitions of fractions right away and dealing with fractions right away, we're going to deal with greatest common factor and lowest common multiple in order to better understand these concepts. And then, after we introduce you to fractions and define the three different types of fraction, we will then be able to apply our greatest common factor and lowest common multiple into how to use them with these fractions. So, the greatest common multiple, as the name implies, greatest common factor, as the name implies, is you're trying to find factors, which are numbers that go into other numbers. You're trying to find the greatest number in those. So, greatest common factor, the beginner's way to do the greatest common factor, if you aren't as 100% familiar with your multiplication tables and what numbers go into what other numbers, the best way to do it as a beginner is to write out all the factors that go into every number that you have to decide between. Okay? So, in this case, we're going to write it out like that. For the greatest common factor, you write out every factor that's in these numbers. And for small numbers down to the double digits, yeah, it can be kind of lengthy, but it's nothing compared to when you start getting to 3-digit numbers, 4-digit numbers, and etc. But for the purposes of what the greatest common factor and lowest common multiple are supposed to be used for, it's very seldom that you'll have to know how to do it to that level. Not going to say it never happens, but for most applications, you won't have to know what the greatest common factor between two 3-digit numbers are, or the lowest common multiple between two 3-digit numbers, right? So most of the time, because fractions we don't usually deal with fractions that are that small to have 3-digit denominators, you don't have to worry about it as much. But do know how to do it to some extent, and write out if you don't know, you can write out all the factors of a number. But let's get back to the topic at hand with the greatest common factor, and we see 8 and 12. Well, the greatest common factor, if you're looking at the factor list there, can you tell what it is? That's right, it's 4. So we'll circle 4 in red. 4 is the greatest common factor between those two numbers. That's right. Now, 9 and 33. Do you see what the greatest common factor between 9 and 33 is? Sorry, my writing might be a little on the small side, but if you said 3, then once again you are correct. And the very bottom example, which is slightly in the glare of the light off of my windows, I do apologize, but the very bottom example, you don't necessarily have to write out all of the possibilities, but the important thing to know here is the greatest common factor between a number that goes into another number is the other number that the number goes into, right? So you can still write out the factors list if you want to. But because 16 goes into 48 3 times, you don't have to do that, right? So 16 goes into 48, then the greatest common factor, is 16. Simply because 16 is a factor of 48, right? So the greatest common factor in that case is going to be 16. So there's some examples of the greatest common factor. Now, for lowest common multiple, or least common multiple, whichever phrasing you wish to use, because I don't particularly believe that least or lowest, it really matters. They both mean the same thing. Lowest common multiple between 8 and 12, right? Well, 8 and 12 both go into numbers that are smaller than the multiplication between the two, right? That's what we're trying to get to. We're trying to get to the lowest number that they both go into, hence why it's called the lowest common multiple, or the least common multiple. So since 8 and 12 both go into a smaller number, you have 48 would be the least common multiple between the two. However, between 5 and 7, because neither one shares a multiple between their multiple, you just multiply the two of these together to get 35. And once again, with this example, just like in this example, the bottom example here, we have 4 and 12. The lowest common multiple would just be 12. Because of the same reason that you have with the greatest common factor being 16 goes into 48, so 16 will be the greatest common factor between the two, since it was one of the numbers you're trying to find the greatest common factor of. Well, the same thing applies for the lowest common multiple. If one of the two numbers is a multiple of the other, then the lowest common multiple is the number that is the multiple of the other. So in this case, since 4 goes into 12 and is a factor of 12, right? Eventually you'll get 12 if you multiply 3 times 4, right? And 1 times 12 is 12. So the lowest number that they both go into is 12. If that doesn't make sense, once again, please tag me in a question, leave it in the comments section, or when I get the Patreon live Q&A stuff set up and live study sessions set up, we'll cover anything that you guys don't understand fully. But I hope for now that gives you a basic understanding of lowest common multiple and greatest common factor, and that we can move into now getting into the types of fractions. So let's go ahead and erase this. If you guys didn't, if you guys wanted to use the information that I had just written up, please feel free to take a screenshot of anything at any time before I erase it. So we're going to go ahead and erase this, and now we're going to get into fractions themselves, right? Once we get done defining the fractions, we'll have most everything we need to do basic mathematics featuring fractions. So, a proper fraction is any fraction where the numerator is smaller than the denominator. So proper fraction equals n smaller than denominator, right? So the numerator will be smaller than the denominator in a proper fraction. Every proper fraction, the numerator is smaller than the denominator. Okay? Once again, if that was helpful for you and you want to hang on to it, please take a screenshot, rewind the video, and please take a screenshot. And if I am not talking fast enough, or you want to hear the lesson go by quicker, please go up to the settings in the YouTube video, and you can find a 2x speed button under the playback speed, and it will make the video play double speed. All right, moving on to the improper fraction. Improper fractions, n larger than denominator, right? So the improper fraction, n is larger than d. The top being a greater number than the bottom is an improper fraction, because that means you are having more than one, or more than a whole part. A fraction is a representation of less than one. A proper fraction is a representation of less than one. An improper fraction is a representation of more than one. So, improper fraction, n is larger than d. Mixed numbers, however, are what you get when you simplify an improper fraction. So, a mixed number is a whole number followed by a fraction. And don't worry, once again, I will be giving you examples of all of these things. But a mixed number is any whole number that is followed by a fraction. Okay? And if you need to, please take a screenshot of that. Or I can go ahead and cover this again for you guys if you need it. Since there might be a little glare on the screen, but I hope you guys can still somewhat read that. I'm going to be getting new curtain rods and curtains to help block out some of the glare, and hopefully make it a little bit easier for you guys to be able to see what I write on the board when I record my videos during the day. But yeah, mixed numbers, whole numbers followed by a fraction, right? Very simple, very rudimentary, basic mathematics here, right? So, let's go ahead and work on some examples here. And we'll also show you how to simplify a fraction. Okay? So, some examples of proper fractions. I'm going to underline all of these types of fractions in a color that I will then write that type of fraction in that color. Okay? So, green and blue are going to be the two more proper ways to write a fraction, and red will be the improper fraction. Okay? So, for the purposes of proper fractions, you have 1/5, 1/4, 1/3, 5 33rds, and so on and so forth, right? Whereas a mixed number, you'll have 4 4/5, 3 6/7, 9 5/8, right? And these are mixed numbers. And then with the improper fractions, you have 16/9, or 23 fourths or 17 fifths, right? And these are some examples of improper fractions. Now, I'm going to go ahead and erase the proper fractions and the mixed numbers because there's really nothing else lesson-wise to do with the proper fractions except when we get into the actual adding and subtracting. And I'm actually not going to erase the mixed numbers because it's going to help us to establish a relationship between mixed numbers and proper fractions. And eventually, why improper fractions exist is going to be explained. But for now, let's erase the proper fractions. And let's just focus on these improper fractions first. So, the improper fractions, the best way to deal with these improper fractions, right, is to what they call simplify them. So, simplifying these improper fractions, you need to find out how many times this number can go into this number and how many remain after that, right? So, a remainder, this is where that remainder in division that we talked about in week 1, that's where this comes into. So 16 being divided by 9, well, that has 1 with a remainder of 7, right? So that means this fraction, improper fraction, is equal to 1 7/9. And that's solving that. Okay? I'm going to do some fancy schmancy artwork here to draw a squiggly line that will divide these so we don't get confused on me having these mixed numbers next to these improper fractions, and don't want you guys to be thinking that I am trying to tell you that those improper fractions lead to these mixed numbers. Okay? Now, 23 fourths, well, the same thing. And this is the only time the remainder is ever useful, is when you're trying to figure out how much remains to put on top of a fraction. Otherwise, the remainder is completely useless in division. So, for the purposes of this one, 23 divided by 4, you get 3, sorry, not 3, yeah, helps if I'm good at math, right? You get 5 with a remainder of 3. So that means there are 5 whole numbers that are a result of this. I'm going to, well, I need to stop using my finger to erase the board. I'm making a mess. Oh no. All right, I'm going to write it over here because an equal sign is the same no matter what direction it faces. So 5 3/4 is the way to simplify 23 fourths. And once again, if you know your multiplication tables and you know basic numbers that go into each other, most of the time you can solve most fractions by doing that. And then 17 fifths. Let's go ahead and erase this division problem so we can make room to do 17 divided by 5. So 17 divided by 5 has 3 times with 2 remaining. So 17 fifths is equal to 3 2/5. And there you go. So that's how you simplify improper numbers, or improper fractions. Sorry, improper fractions into mixed numbers. All right. However, there's a problem with mixed numbers in that they don't really like to play nice when it comes to multiplying and dividing and adding and subtracting. Mixed numbers with adding and subtracting is not as hard, but multiplying and dividing mixed numbers with fractions is where you start to get into a little bit of trouble. Okay? So we're going to go ahead and erase all the examples I've got so far so that we can get into the meat and potatoes, right? So, fractions, adding and subtracting fractions, right? Well, when it comes to these fractions, pardon me, I'm looking at my notes here. So for adding and subtracting fractions, we're going to have to get a concept introduced here that is based on this lowest common multiple / least common multiple, whichever one you want to use. We have to do a new concept based on that called lowest or least common denominator, right? Or LCD. So the least common denominator is going to have to be something we find in order to do addition and subtraction of fractions that don't have the same denominator. So let's go ahead and write a couple fractions up here to add. So I want to add 2/5 and 3/4, right? So 2/5 plus 3/4 is going to equal what? Well, I can't really do that problem as it stands because they don't have the same denominator. So the number on the bottom here isn't the same, so I can't really add these two together to figure out what the value between the two is going to be. So now we got to figure out what the least common denominator is going to be between these two numbers, which means we have to figure out what the lowest common multiple between 5 and 4 is. And the lowest common multiple between 5 and 4, that's right, it's 20. Unfortunately, in this case, you have to do one extra step in order to get the denominators to be 20, which is you have to multiply these by a form of 1. Never forget that the fraction that you are multiplying both of these numbers by is a form of 1, because if you do not multiply it by a form of 1, you are changing the value of these fractions, and indeed numbers in general. If you don't multiply it by a form of 1, you are always going to be changing the value, and therefore it won't be the same fraction that you're trying to add. So always, 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 when you are trying to do this, you're going to multiply it by a form of 1 in the form of whatever number you have to multiply the denominator by to get to the lowest common denominator is whatever number you have to multiply the numerator by. So 2/5, and then we're going to put the plus sign here, 3/4 in the parentheses that I have included here. We have to create a form of 1 that will give us a denominator of 20 for both of these numbers. In this case, for the 3/4, we have to multiply it by 5/5. And it's 5/5 is a form of 1 because the 5s divide into each other once, right? And in this case, it is 4/4. You have to multiply the numerator and the denominator by the same number so that the value stays the same. Okay? Now that we have done that, 2/5 becomes 8/20, and 3/4 becomes 15/20. And now we can add the two together. And adding the two together, remember, the denominator isn't changing, only the numerator. So the best way to imagine this in this particular instance, right? is a pie chart, actually. Now, I'm not good enough to draw this into 20 parts. So forgive me, I'm going to use a different fraction for this purpose. When it comes to adding, the denominator stays the same because the whole part that you are trying to figure out how much of you're using stays the same. The denominator is the same for both numbers, and it stays the same for addition. Okay? Whereas the numerator changes because you're saying, I have green, the green part that I'm going to highlight, and I will try to shade this a little bit. Sorry. Shade this a little bit so you can see. Okay, so the pi squares, I had this drawn into eighths. So let's say I have 3 green eighths, right? Right? 3 green eighths. And 1 blue eighth. And I'm adding 3 eighths, 1 eighth, and 3 eighths. Right? The eighths doesn't change because the eighths is the parts of the whole that you're trying to talk about. But the rest changes because these are the individual parts. The 8 represents the whole. All 8 pieces is 1. If you have all 8 in the top, then you have 8 over 8, which is 1. The 3 represents how many are actually being used on this part. And the 1 represents this one that's actually being used on this part. Right? So, let's see if I can hold something up to kind of shade that. That's not really working. So, you can kind of somewhat see my not that great art if I hold it up at the right position. My hand's not quite big enough to block out that glare. And once again, like I said, I am working on getting some curtain rods and new curtains to put up and make it so that this isn't quite so much glare when I'm filming. Now, these 3 eighths and that 1 eighth come together to become 4 eighths, which is not a simplified fraction. 1/2, right? I hope that makes sense. If it doesn't, like I said, please let me know. But the denominator represents the whole, the one thing you are trying to go for, the one thing that you are representing parts of. The denominator is always the whole, and the numerator is the part. Okay? So let's go ahead and erase this so that we don't get any more confusion with it being right next to this other addition problem that we're working on right now. Right? All right. So now, 8 plus 15 is 23. So it's 23 20ths, right? Well, that's an improper fraction, right? So we have to simplify that down. If this is the final answer and we don't have any more work to do with that fraction, then we simplify it down to be 1 3/20. And that is the final answer on what 2/5 plus 3/4 is going to give us. 1 3/20. And if everybody thinks that makes sense, then I will prepare to erase this. So please take a screenshot if you need to. Okay? And I will erase this and move on to subtraction, which is the same process, just subtracting. right? Well, we'll use a new example so that it's a little bit more solidly placed in our minds, right? All right, so new example. Let's use blue to start us off. Oops, dropping stuff over here. All right, blue to start us off with, let's say 5/6 plus 9/22, right? Gonna get a little bit more hairy on this one, right? Let's actually go with a simple example. Let's get a simpler fraction thrown in here. So 5/6 we'll keep. Don't know why I erased it. I'm kind of silly today. 5/6 plus, let's go with 7/8, right? And, my bad. I'm also doubly silly because we said we were going to do subtraction now. I am all over the place, guys. Pardon me. All right, so we're going to go ahead and do 7/8 minus 5/6. So 7/8 minus 5/6. Well, we need to find what the least common multiple between 8 and 6 is so that we can then solve this fractionary problem, right? So, in this case, 7/8 will be multiplied by a form of 1, once again, and 5/6 will also be multiplied by another form of 1 in order to get us the least common denominator, lowest common denominator, between 8 and 6. And the lowest common denominator between 8 and 6, does anybody know what it is off the top of your head? If you said 24, you'd be correct. So, when it comes to the 7/8, we need to multiply 3/3 by 7/8. Okay? And when it comes to the 5/6, we need to multiply 4/4 by 5/6 to give us a fraction over 24. Okay? So, in this case, this will be 21/24 minus 20/24. Okay? And obviously, very basic math at this point. Now it becomes 1/24. And since that is a proper fraction, that is the only answer that is an option. So 1/24 is our final answer. Once again, the denominator stays the same between these two because the denominator represents the whole, the numerator represents the part. I hope that makes sense. And once again, I'll leave this up here for a moment so you guys can screenshot the example that you need. All right, going over exit. All right. And that is very basic math with fractions. I'm going to have to wash that eraser soon. All right. So, now, let's talk about, let's go ahead and erase all of this, right? Because that stuff is mostly necessary for addition and subtraction. Not so much. I mean, the proper improper fraction as well as the mixed number stuff and simplification of fractions is going to be necessary no matter what. But the lowest common multiple, least common denominator, and greatest common factor are all going to be not quite as big a deal when it comes to multiplying and dividing fractions. Okay? So multiplying fractions is simple. You multiply all the way across the board. So I'm going to write up here that we're multiplying fractions. Multiplying fractions. Okay? So if we're multiplying fractions, you multiply across the board. So let's say 2/5 times 3/4, right, is going to be 6/20. And that's not a simplified fraction because these numbers can both be divided by 2. So then it's 3/10. And that's multiplying fractions. It is very, very simple. There's nothing really to it when it comes to multiplying fractions. And if you have at any point in time to make it simpler for yourself, I didn't necessarily do this off the bat because I wanted to show you that it's cross multiplying all the way. But to make it even simpler, you don't even need to simplify the fraction afterwards, because when you multiply fractions, if the numbers that are diagonal from each other, so let's change this multiplication sign, right, to point directly between the numbers, okay? And boom, right? So now this multiplication sign shows us that we need to compare these numbers. And it's not just a multiplication sign anymore, it's just a symbol to show us that we need to compare these numbers before we go ahead and do the multiplication too. And since 2 goes into 4 2 times, and 1 time for itself, we can reduce that down. So now it's 1/5 times 3/2, which is 3/10. Yes, you have reduced that down and it has created an improper fraction, but for the purposes of the equation that you're solving, it doesn't change the value overall. So 1 times 3 is 3, 5 times 2 is 10. And you get the same answer. Very simple, very, very rudimentary. Don't have to worry about having a whole bunch of extra steps to do, like when you're doing addition and subtraction, and you've got to get the lowest common denominator so that you can do that, or the greatest common factor and stuff like that is going to be where this comes in. The reduction is the greatest common factor usually, as well as simplifying a fraction down to its smallest parts, right? That's going to where the greatest common factor comes in. That's more necessary for that. But you don't necessarily have to do that every time. You just need to be able to understand that when you write the fraction out, if it's, like, obviously if it's 2 even numbers over each other, chances are you can simplify that down. And basic stuff like that, right? So leave that up, and hopefully you took a screenshot of the other before I erased it. All right, time's up. All right. Now, we're going to go on to dividing fractions. Dividing fractions, in this case, we'll use 2/5 times 3/4 again. I know, they're my favorite. Not 3 times 3/4, but divided by 3/4. So 2/5 divided by 3/4, right? Well, this is where the weird part comes in, right? You're already dealing with division here. If you remember back when I was explaining in the first video about definitions of mathematical operations and such, we said that the most common division problems that you're going to run into are fractions. Because you're dividing 2 by 5. The top number is getting divided by the bottom number every time. So you're dividing a division problem. Kind of weird, right? Well, when it comes to dividing fractions, you simply multiply by the inverse. Now, what does that mean? Well, one of these two fractions needs to literally flip upside down. It doesn't particularly matter which, but typically you'll go with the one that's on the right-hand side of the division symbol. So 2 divided by 2/5 divided by 3/4 is the same as saying 2/5 times 4/3. Okay? And therefore, the answer is 8/15. 8/15. Right? So we cancel and we cross cancel when it comes to multiplying, right? But when it comes to dividing, you don't cancel or cross cancel because the values don't. Since you're not multiplying until you've inverted it, you can't cancel. So the best way to think of it, like I said, when you have the division symbol here, notice that they're not pointing at their numerators and denominators. Once you've turned multiplication, or once you turn division into multiplying the inverse, now you can cross cancel if you have the opportunity to. But in this case, unfortunately, we don't have the opportunity to. So it's not until you see that little cross there. And yes, I know that multiplication is not always, and nor is it even frequently, in higher level mathematics, do you see a X there. But the X actually, for the purposes of this exercise, makes it a lot more useful to have the X symbol there for the multiplication, because like I said, now when you see that X symbol there rather than that division symbol there, now you know that you can cross cancel if there's an opportunity to. In this case there isn't, but there are several cases that you'll encounter that there is. So once again, division of fractions is multiplying by the inverse. Sound good? That makes sense? I can do another example. I'll go ahead and try another example with you guys. That way we can get a little more comfortable with it. But multiplying, I didn't really feel like needed more than one example. I felt like that was a pretty simple thing to grasp. And if it isn't, once again, please, Shinrai Sensei 15 on Twitter. Just at me on that. Ask me the question. Come over to my Patreon. Ask me the question on the live Q&A stream. Leave it in the comment section below. Any particular way you can find me, you go ahead and reach out, and I will be more than happy to answer the questions. Okay? Let's go with 3/7 divided by 9/16. Well, that's going to be 3/7 times 16/9, and that's equal to 16/21. 16/21 is what we get when we simplify 3/7 divided by 9/16. It's 16/21. Everybody comfortable with that? Everybody clear on that? All right. So I think now we should just do a couple examples of every single one of the type of problem that we were dealing with today, so that we can get a really good feel for exactly where we're at. Okay? So I'm going to write out some problems here. right. So we've got examples of every one of these math problems that we talked about today. And the best way to deal with this, right? Addition and subtraction. We need to find the lowest common denominator for both of these. Okay? So 7 and 16, unfortunately, there's no number between 7 and 16 that you're going to be able to get a denominator on. So you need to find 16 times 7, which is going to be and let's make this a little simpler for the addition one, right? Let's give it a little simpler example problem for the addition one, mostly because my math skills are not what they used to be. No, but let's go with 5/8, right? Instead, make it a little simpler for myself. So once again, 7 and 8. You have to find what 7 times 8 is because neither one of them have a common, common factor, or not common factor, common multiple that is lower than the multiple between the two. And the same with 9 and 7. So we got those two numbers that we need for those. So let's go ahead and do this. 3/7 times 8 over 8 plus 5/8 times 7 over 7 is equal to 24/56 plus 35/56, which now that's equal to 59/56. And since that's the final answer that we need, it is 1 3/56. Right? Quack, quack. All right, so 1 3/56 is the simplified version of the 59/56 for the improper fraction version. Okay? Now, 4/9 minus 1/7, 4 over 9 times 7 over 7 minus 1/7 times 9 over 9 is equal to 28/63 minus 9/63, which is equal to 19/63. I don't know why I put 16s. 19/63. Right? Multiplication, super easy. It is 15/36. No, 30 seconds. Once again, proving I'm not very good at my math problems anymore. 15/30 seconds. Okay? And that can't be reduced any further because they don't share any common factors other than 1. So 15/30 seconds is the proper form for that one. And 9/16 3/4 would be 9/16 times 4/3, which is 3/4. Isn't that fun? Yeah, it's kind of confusing how that works, isn't it? 9/16 getting 3/4 dividing 3/4 into 9/16 and getting 3/4 as the answer is kind of interesting, isn't it? But yeah, there you go. So there's some examples of each of those for you, and you can go ahead and copy those at your leisure, or just take a screenshot of them and have your answer. But I think that that will just about sum up Math Episode 2, and I hope that you guys will help me improve as a teacher. Please don't be afraid to levy some criticism against me. If it's, good faith criticism and we're just trying to improve and get better together, like the goal of this channel is and the goal of this YouTube series is, I will be more than happy to take any criticism and learn from what you guys have said. If it isn't good faith criticism, I will just ignore it. So please, just like I said, if you're going to have criticism and going to have things to say, please make them constructive criticism that I can actually grow from, and not just bad faith calling me ugly or something like that, or calling me stupid. Actually have something to say. It's not exactly a testament to you if you just want to leave nastiness in the comment section. So if you guys do have any questions, like I said, please feel free to at me, Shinrai Sensei 15 on Twitter. Leave a comment in the comment section below if you have any questions. And also, I will be organizing a study session live stream, 2 hours. I will be working on setting that up. I think I might start it on YouTube and then eventually move it to Patreon so that you guys can see that it is actually happening and that I will be conducting it. Will not start until probably the week of April 17th at the earliest. That way you guys can get a feel for the content, get a understanding of me and what I'm trying to do, and also just so that we can get to know each other a little bit better before we go ahead and launch the new lessons and launch the study program together. I will, if nobody joins into the live streams on the April 17th live stream stuff, if I have a couple weeks where nobody's joining into the live streams, I might consider canceling them. But for the 2 weeks after I start, all the way into the first week of May, I will be doing Monday to Friday live stream study sessions. If nobody joins, it will just be me listening to classical music while I study Japanese. And I hope I will get some questions to answer, and hope I can get some people to interact with. But I'll do 2 weeks of it, and we'll see how that goes, and we will answer any questions you guys have at earliest convenience, okay? Please feel free to leave questions. I look forward to helping you guys, and you guys are helping me become a better teacher by asking me questions and making me research the answers. Okay, so please just let me know. I really want to be able to become better at this and help you guys. So once again, questions can be directed in the comment section or at Shinrai Sensei 15 on Twitter. I will be setting up a Patreon account so you guys can support me. I will hopefully be able to get some things going so that I can maybe do a supporter live stream where you guys can come on and directly speak with me about any questions that you have, or if you just want to, pontificate about the nature of the universe or something, we can go ahead and do that. But for now, I think that's where we're going to leave this at today. And thank you guys so much for coming out. And please, please join me next week.